Good morning, OHS geometry students. Are we ready for a little section 1-7 today, which is over transformations in the coordinate plane? Yes, it's time for your most favorite class, the iPad Initiative Geometry class. Alright, so for notes today, we have section 1-7, which we already said was transformations in the coordinate plane. Looking at the objectives today, we're going to identify some reflections, rotations, and translations. Some of you guys might already know what this is about. And then we're going to graph those transformations in the coordinate plane. Again, you can read through the Y by yourself. And the other class will answer the number 5, but quite haven't figured out how to work that into your lesson yet. Alright, transformations. This definition is one of them that I found out on the internet, but I'm not sure it's the best definition. It says transformation is a one-to-one relation between a set of points in the plane or space or another set of points in the same plane or space, where each point in a set has precisely one and only one corresponding point in the transformed set. Wow, that's a mouthful. Let's see what else is on this page. I think the reason why I went ahead and developed this page is we could go ahead and talk about some of those transformations on it. So, draw this down real quick. So, some of these, if you notice, if I click on this box here, then another box appears. So if I was to take this and slide it down, that would be one of the transformations that we would have a slang term slide for, but its real name is going to be a translation. So if I take an object and I slide it somewhere, so I have that same shape, just down or to the side or above, or up above and to the side, then that's a translation. If I click on the ball here, you notice it gets bigger. Like when you go to the eye doctor and they put that little liquid eye drops in your eyes, it makes your pupil get bigger so they can see in your eyeball a little bit better. Well, we call that a dilation, and they call it that at the eye doctor also. Alright, if I click on this, it's going to unfold right there, and we see the mirror image reflected on the other half of the leaf. We call that a reflection. And if I click on this thing, it's going to spin or turn, and a turn is called a rotation. So if there's a fixed point there and I just spin that, then that is going to be a rotation. Alright, I think I've got some more examples of those on this page. So if I click on the little monkey, it slides over. So if I'm sliding it anywhere in the coordinate plane or on the paper, if I'm just sliding it, not turning it, not flipping it over, not making it bigger and smaller, if I'm just sliding it, it's a translation. Okay, the little owl here will spin. So if I'm spinning it or turning it, that's going to be a rotation. Well, if I flip it over, that's going to be its reflection. And then the frog, if it grows or gets smaller, changes its size, that's going to be the dilation. So those are your 4 types of transformations. Alright, I think I have a little shorter definition. This is probably the better definition to write in your notes to write in that big long definition on the other page. So a transformation is just a change in position, shape, or size of the figure. Okay. I got some transformers up there on this page that looks pretty cool to help you remember transformations. Okay, the image is where the new figure lies. So if I was to take this and move it, then where I moved it to would be the image what I would call the original shape before I did the translation, I would call it the pre-image. So when I took it and I slid it, I created a new image where the original shape is called the pre-image. That's important. Make a note of that real quick. Okay. I got another example here where I flip this triangle over a line. That would be right through here. So the pre-image is the original one, and the red one here would be its image. That would be where I would have flipped it to. Prime notation. Okay, this is called A prime. That little tick mark is called a prime mark, and it indicates the new image. So ABC is the original, and A prime, B prime, C prime is the new image. Okay, so just A, B, and C we call the pre-image. The primes on them would indicate after the move or the image. The little tick marks we call prime notation. Alright, another little notation. I have the same little reflection going on here as on the previous page. So I'm going from the black triangle to the red triangle, and this is called arrow notation. So I have the original one here in black, which is triangle ABC. This is mapped into the red triangle, which is triangle A prime, B prime, C prime. So that's how we would use arrow notation to indicate one of our transformations. Alright, let's move on. So we've already talked about a translation being a slide. So I've got a little bit more on it on this page. It says it can be described by starting how many units to the left or right the figure is moved, and then how many units up or down. Okay, so I could move it up or down. That's still just sliding it. Could move it left, up, and down. So wherever I just slide it to, that's a translation. So a slide is a translation. The size and shape must stay the same. It's only a new location on a translation. Alright, every point is moved in the same distance in the same direction. So as you can see, it goes from the black to the red, and it's just sliding it to a new location. No size change, no turn of point A, to A prime. It's just a slide. Okay. All right. This page here, if you wanted to work through, it is on the Smart Notebook that's uploaded to your site. I think right now I'm going to go ahead and jump past it and talk about this page. Okay, as you notice on this page, we're still dealing with translations or a slide, but now we got to write a rule that would move a point 3 units to the right and 5 units down. Well, if we remembered order pairs, the x is the first value and the y is the second value. So if I'm moving it left or right, then yes, I'm changing the x value. If I'm moving it up or down, then yeah, I'm changing the y value. So it stays the same for this, and how I would write this rule is I would still have my x value, like if it was, over here at 5. Well, if I'm moving it to the right 3 units, then I would take that 5 and I would add 3 to it. So to represent that, I could just write x plus 3 to do that in arrow notation. If I was moving it to the left, I would subtract it. Okay, and to move it down, well, I would take y, and downward would be a minus 5. So if I'm moving it 5 units down, I would have to take 5 away from the y value. And that makes sense. So if I was to move it down here 5 units, this y value would change from 0 to negative 5. Alright, well, sometimes they're just going to move us up or down or just left or right. So that would just mean that the variable that you're not moving just stays the same. So xy, if I'm just going to move it 6 units down, the x value doesn't change. Moving it down would just affect that y value. So my y would be minus 6. Now this one, notice, I'm not moving it up or down, I'm just moving it to the left 8. So for this one, the x is going to change, and to move it to the left, you need to subtract the 8. And the y does not change whatsoever. Okay. So one quick example here. It wants us to graph the triangle x, y, and z, and it gives us the locations of each point. So I'm going to come over here to the coordinate plane, and I'm going to graph negative 6, negative 6, and that's my x. And then I'm going to graph y at negative 2, negative 1. Then I'm going to graph z at negative 2, negative 6. So there's my triangle, and I could draw the lines in here to connect it if I wanted to. So that's my pre-image. And then it wants me to graph the image of the triangle x, y, and z, which we could call x prime, y prime, z prime, after a translation 7 units to the right and 4 units up. So all I'm going to do is move each one of these vertices of the triangle 7 units to the right and 4 units up. So I'm going to move the y first here. I'm going to go 1, 2, 3, 4, 5, 6, 7, and up 1, 2, 3, 4. I'm going to put my new point down there. I'm going to go ahead and call that y prime. Now I need to do it to the other 2 points. So I'm going to move my z next. 1, 2, 3, 4, 5, 6, 7. Up 1, 2, 3, 4. I'm going to put my point right there and call it z prime. And now I'm going to move my x 1, 2, 3, 4, 5, 6, 7. Up 1, 2, 3, 4. And that's my x prime. So my image now would be right here, the black one. Alright. So we moved the red triangle to the black triangle this time, and when we did, we labeled it x prime, z prime, and y prime. Part C here just wants us to list the coordinates of each one of those points. So all I have to do is look on my graph here. So like y prime would have the coordinates 5, 3. And notice if I was to take my original y here and add 7 to that negative 2, I would end up with the y. And if I moved it 4 units up, I would be adding 4 to the 1, which should give me that 3. So it does work out that way also. Okay, so my x prime then would be at 1, negative 2, and my z prime would be at 5, negative 2. I'm going to go ahead and end part 1 of section 1.7 at this time.